Okay, now we're going to start working on differentials, dy. All right, so what this does is this starts to get us prepped for integration, right? So find the differential dy. Well, first thing you're going to do is take the derivative of each side, so dy dx on the left. But remember, when you have a rational function like this, you could do the quotient rule, or remember it's going to be the opposite sign and then 3 over x squared. So that's the derivative, and that's all the work you'd have to show me because we're past the derivative rules. And then the very last thing that you're going to do is multiply both sides by dx. Just like that. All right, we're going to go on to the next. Okay, now for each problem, find the differential. Well, first thing you're going to do is take the derivative. But when it's a square root, remember what you want to do is rewrite it as with a fractional exponent. And don't forget the negative sign there. So now when you take the derivative, this is going to be a chain rule, right? So the 1/2 will come in here, and then 1/2 subtract 1, or 2 over 2, is negative 1/2, and then this piece right here will go in the denominator. And there's two ways you could write it in the denominator. You could write it x to the 1/2, but to the 1/2 power also means square root of x. So I tend to like to rewrite it as a radical, but leaving it as a fractional exponent is perfectly fine. And then you're going to multiply both sides by the dx. All right? We're going to, and I'll just walk you through this. We're going to take the dy dx of both sides, so that will be negative 2 over x squared. I'll put that in parentheses, and then I'll multiply both sides by dx. So dy is equal to negative 2 over x squared dx. And that's the differential, now dy. And then what that leads up to is integration. When you have dy on this side and dx on this side, you can integrate, whoops, that's not a very good one, both sides. All right, that's it for this one.